MCERT. Welcome to my channel, Learning Builds Life. Today we are going to talk about indices. Let's take a look at today's sum. Prove that 1 by 1 plus x to the power of b minus a plus x to the power of c minus a plus 1 by 1 plus x to the power of a minus b plus x to the power of c minus b plus 1 by 1 plus x to the power of b minus c plus x to the power of a minus c is equal to 1. Here our LHS is this entire expression and RHS is 1. Well, we have to prove LHS equal to RHS. Let's do it. LHS is equal to, and now we have to copy this entire thing down. 1 by 1 plus x to the power of b minus a plus x to the power of c minus a. And here a little bit extension to be done. Like that. Yes. Plus 1 by 1 plus x to the power of a minus b plus x to the power of c minus b plus 1 by 1 plus x to the power of b minus c plus x to the power of a minus c. Now we can continue solving this. Equal to. Now over here in the first fraction we can see that the common exponent is common power is minus a in this case. So we have to multiply x to the power of a. Similarly here we have minus b as the common power. So here we have to multiply x to the power of b. And here we have common power as minus c. So we have to multiply x to the power of c. And after we multiply, we will see what can be done. So let's multiply. If we are multiplying here, we have to multiply numerator as well. So x to the power of a by x to the power of a into 1 plus x to the power of b minus a plus x to the power of c minus a. That's our first fraction. The second one, x to the power of b by x to the power of b into 1 plus x to the power of a minus b plus x to the power of c minus b. We have that. Plus our third fraction, which is we have to multiply x to the power of c, x to the power of c by x to the power of c into 1 plus x to the power of b minus c plus x to the power of a minus c. We put the bracket there, and we are done with our second step. Now, using the distributive method, we will multiply. Let's do it. X to the power of a by x to the power of a plus x to the power of a plus b minus a, because we will apply this identity in case of all of them. The identity is if it's like p to the power of m into p to the power of n, it's equal to p to the power of m plus n. Keeping that in mind, we get it's actually x to the power of a into x to the power of b minus a, hence we are adding it. Same for x to the power of c minus a. We will write that as x to the power of a plus c minus a. And same in case of the other two fractions. Let's do them. X to the power of b by x to the power of b plus x to the power of b plus a minus b plus x power b plus c minus b. We got that, and now for x power c fraction. This may not fit, but let's see. X power c by x power c plus x power of c plus b minus b, b minus c, plus x power of c plus a minus c. Okay, now we can see that it's possible to cancel a and a over here, a and a here as well, b and b here, b and b here, and c and c here, c and c here. Then we are left with x power of a by x power of a plus x power of b plus x power of c plus x power of b by x power of b plus x power of a plus x power of c plus x power of c by x power of c plus x power of b plus x power of a. Now I may take a look at the board. Moving on to rest of our proof. Continue proving this. We left off at this state. Now, if you notice carefully, we can see that all of the denominators are actually the same thing. That is x power of a plus x power of b plus x power of c. Because if we rearrange, like here also, it's BAC, means the order of powers is BAC, but if you rearrange, you get the same thing as ABC. And same in case of the third fraction. So we can write this, and on top we have x power of a plus x power of b plus x power of c. Then we can write this as x power of a plus x power of b plus x power of c by x power of a plus x power of b plus x power of c. Now we can cancel this entire thing to get 1, which is our RHS. So we could ultimately prove our LHS and RHS equal. That means this entire expression equal to 1. This is proved. Now I may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe my channel, and stay tuned for more videos. Thank you.